I wanted to take a couple of minutes to preview lessons 8.1 and 8.2 with you. These are all going to be formulas and concepts that we studied extensively in Algebra 2 on arithmetic sequences and geometric sequences. So let me take a minute to review on what that is, and then also you'll need to have your blue note card, and we're going to work on the section that's called 8.1 and 8.2 Formulas for Sequences. You'll notice on that note card that I have provided for you the explicit and recursive formulas for both arithmetic sequences and geometric sequences. First of all, let's go back and let's talk about what a sequence is. You know, a sequence is just a list of numbers. And so we'll be writing some of the terms out for these different sequences that we can identify down here in these first problems on this Lesson Master 8.1a. Let's also talk about the difference between explicit and recursive. We know that a recursive formula has to do with this bracket on the side here. And what that has to do with is the fact that a recursive formula, in order to know the next term, we have to build upon the previous term. So you will see, for instance, something like in the formula where it says a sub n minus 1, and that's going to be denoting the previous term. That will stand for the previous term. That notation will. And typically you'll see the formulas written on your note card anyway for the arithmetic using the variable lowercase a and the geometrics using the lowercase g for the variable. That will not be true when you start looking at the problems. It would be a little too obvious if we always used a and g, so you'll see them use a variety of different variables. But you can think back in terms of whether or not they would be arithmetic or geometric, and you can always rewrite them in terms of a and g if you want to. Explicit formulas are like the formulas on the left side of the note card, and they give you explicitly the formula for the sequence of numbers that you will be looking at. In other words, it's explicitly going to just tell you what exactly whatever term you want to know. All right? All right, so with arithmetic, you might remember that arithmetic have what we call a common difference. So if each number in the sequence goes up or down by a fixed amount, it could always be an increase of 5, for example, or a decrease in 3, something like that. That common difference would make it an arithmetic sequence. A geometric sequence, on the other hand, is going to have a constant, what we call ratio. In other words, if I take a term and divide by the previous term, I will always get the same fraction or whole number. All right? All right, well, what we're going to do on this worksheet, just to get our feet wet again and talk about these like we have in the past, is we're going to go back and we're going to do 4 things. On Part IA, we're going to identify the formula as either recursive or explicit. Now, the hint here is going to be, you'll notice all the recursive ones have the set notation, where you have kind of roped off on the left-hand side what the first term is and then what every term thereafter would be. Explicit will just be explicitly written as a formula like those on the left of the blue note card. After we do that, we're going to find the first 4 terms of the sequence. Then the next thing we're going to do is find the 10th term. And last but not least, we're going to identify this sequence as either arithmetic, meaning it has a constant difference. So it goes up or down by adding the same number or subtracting the same number each time, or could be geometric. That means we're going to be having a constant ratio or multiplying by the same multiplier every time, or it could be neither of the two. Okay, well, let's just look down through this list of problems on 1 through 6, and let's mark them all for Part A as either explicit or recursive. You can pause this video, and if you think you already know all the answers to it, you could go ahead and fill in Part A on each one. If not, I'm going to talk you through it here. On number 1, we're going to call this one recursive, and I'm just going to put an R for recursive. Number 2 is the explicit formula. Number 3, again, I see the set bracket. This one is going to be recursive. On number 4, I see a formula all spelled out. That's going to be explicit. Number 5, again, I see a recursive formula. And on number 6, I see an explicit formula. So if you can identify the difference between those, that's the first step. Now we're going to find the first 4 terms. Whenever I have a recursive formula, they're going to spell out for me what the first term is. So that's going to be -4. Then the way we would read this part would be to say that the next term is -3 times the previous term. This stands for the previous term. All right, so if I take -3 times the previous term, I'm going to have +12. Now if I take the third term, r sub 3 is going to be -3 times r sub the previous term, r sub 2. Remember, this one's r sub 1, and this one's r sub 2. So r sub 3 will be -3 times the previous term. -3 times +12 would give us -36. And then the fourth term is going to be -3 times the previous term, r sub 3. So -36 times -3 would be +108. So those would be the first 4 terms. Okay, if you want to do this on your calculator, there's some features on your calculator that could make this pretty convenient for you to do or to use. Let me move this. Let me do this. Kind of get it out of the way. Well, I think I can talk you through it. You can still see it on your paper. Okay, I'm going to start with -4, and after I put the -4 in the calculator, I'm going to hit Enter. Okay, then I'm going to say, now I want to take that term times -3. And so there's my second term. Then if I just hit Enter again, there's my third term. If I hit Enter again, there's my fourth term, and so on and so on and so on. I'm supposed to be finding the 10th term right here. I'm supposed to find r sub 10. If I wanted to find r sub 10, and right now on this calculator I have my first term, second term, third term, and fourth term, I'm going to keep hitting Enter. There's the 5th term, 6th term, 7th term, 8th term, 9th term, and the 10th term. So the 10th term is 78,732. 78,732. And last but not least, it wants to know if this is geometric or arithmetic. Okay, I will check for arithmetic first. If I went from -4 to +12, I would add 16. And if I went from +12 to -36, I would not be adding 16 on. So it cannot be arithmetic. It could, however, be geometric. If I take 12 and divide by -4, I get -3. If I take -36 and divide by 12, I get -3. If I take +108 and divide by -36, I get -3. So there is a constant ratio each time, making this one geometric. Okay, let's look at number 2. Number 2 says we have c sub n is equal to the opposite of n plus 7. So the first term, I'll write down below here, c sub 1. I'm going to find 4 terms altogether. The first term means I'm going to stick a 1 in for n, so the opposite of 1 plus 7 would give me 6. Then if I go back and put a 2 in for c sub 2, I'm going to get 5, aren't I? When I put a 3 in for n, -3 plus 7 is going to give me a 4. And if I would put 4 in for n, -4 plus 7 is going to give me 3, isn't it? Now, is this one that I could also put in my calculator? Well, let's see. If I start out and I have my first term I said was 6, and then if I take 6, well, unless I would know I'm subtracting 1 each time. You know a better way to do this one? Put this in your y equals. We'll put this formula in because it's explicit. We'll put in the opposite of x plus 7. And then let's go to the table. And let's start the table on 1, since I want the first term. And let's go to our second table set, which is second graph. When it's 1, I've got a 6, and then a 5, and then a 4, and then a 3, and a 2, and so on. If I want to find the 10th term, I could find it on the table this way and say it's -3. Or the other way I could do this to get the 10th term is to say c sub 10 is equal to the opposite of 10 plus 7. It's pretty easy when I could do it in my head. This is going down by 1 each time between each consecutive term, so this one has a common difference, making it arithmetic. Okay, We say number 3 is recursive. We know that if I write out my little list of terms here, b sub 1, b sub 2, b sub 3, and b sub 4, the first term is 0.5. Let's see if we can use our calculator to solve this one. Okay? I'm going to move it over here out of the way. Okay, it says that we have 0.5, and then we want to take that answer and we want to multiply it times 2 and subtract 0.25. And when we do that, we get the second term is 75 hundredths. Okay, now let's see what happens if I hit enter again. The third term is 1.25. Let's see if that's right, 1.25. Is that twice my second term? Twice 0.75 would be 1.5 and subtract 25 hundredths, and it is, isn't it? Okay, if I hit enter again, I get 2.25. That would be twice 1.25. That would be 2.5, and 2.5 minus a fourth is 2 1/4. Okay, well if that works, then we should be able to take our 1, 2, 3, 4. Here's our 5th, 6th, 7th, 8th, 9th, and our 10th term. Our 10th term is 128.25. The 10th term is 128.25. Okay, this goes up by 25 hundredths, then it goes up by 50 hundredths, then it goes up by 1. So it's not arithmetic. Our other choice is that it could be geometric. To be geometric, 0.75 divided by 5 would have to be in the, 0.75 divided by 0.5 would have to be in the same ratio as 1.25 divided by the previous term, which is 0.75, and it is not. So this one is an example of a neither. It's neither geometric nor is it arithmetic. Okay, I'm looking at number 4, and I see that I have an explicit formula. And I'm thinking to myself, it's very much polynomial looking. And so I think the best way to attack this, rather than substitute 1 in for n and have to cube it and square it and take it times negative 48 and so on, and then substitute in 2 and then substitute in 3 and so on, I think it would be easiest if I put it in my calculator in my y equals. So I'm going to do that. And then let's double check it. We have negative 6x to the third plus 27x squared minus 48x plus 23. So again, I'm going to use my table. I can go to my table set here. I'll go back to the first term, which is 1. And here are the numbers on my table. So the numbers in the sequence will be negative 4, negative 13, negative 40, and negative 121, because I just want these first 4 right here. So negative 4, negative 13, negative 40, and negative 121. Okay, and then it wants the 10th term. So I'm just going to come down here to where it says 10. And I see that the 10th term is, I think it's T sub 10 this time, negative 3,757. Okay, this is going to be going down by 9 and then going down by more than 9, so it's not arithmetic. 13 divided by 4 and 40 divided by 13 do not give me the same ratio, so this function is neither. Okay, let's try number 5. In number 5, we have that g sub 1, or j sub 1 is equal to 3. Then I want j sub 2, and j sub 2 is the previous term squared. So 3 squared would give me 9, wouldn't it? And then j sub 3 is going to be this term, 9, squared again. 9 squared is 81. And then j sub 4 is going to be 81 squared. I don't know what that is. Let me see if I can get my calculator to help me. 81 squared is 6,561. Okay, now let's see if we can generate this one in our calculator. Okay, I'm going to start with 3 and I'm going to hit enter. And then I want to take that answer and I want to square it. That's how I'm going to get 9 for the second term. If I square that, I'll get 81 for the third term. If I square that, I'll get 6,561 for the fourth term. Then this would be the fifth term, the sixth term, the seventh term, the eighth term, and then I get an overflow on my calculator. So what am I going to do to figure out that 10th term? I can't write down overflow. Well, what I can do is I can look for a pattern on this. The first term was really 3 to the first, wasn't it? Okay, the second term, 9, is really 3 to the second power, isn't it? The third term, 81, is 9 squared, but 9 squared would be 3 squared squared, which would be 3 to the fourth. Making this one, what's happening to my powers here? 1 doubled to 2, 2 doubled to 4. This is going to double to 3 to the 8th, isn't it? The next one will be 3 to the 16th, and then 3 to the 32nd, and then 3 to the 64th, 3 to the 128th, 3 to the 256th power, and then 3 to the 512th power. Now, even though I know it's 3 to the 512th power, I'm not going to be able to go in here and say, I want to know what 3 to the 512th power is. Again, my calculator can only do up to something times 10 to the 99th power, and this is overflow. It's bigger than that. So I'm just going to be able to write my J sub 10 as 3 to the 512th power. If we had a TI-89 calculator, we could figure that out, couldn't we? I think they have more decimal places for us. Okay, this doesn't go up by a constant ratio. 9 divided by 3 is 3, but 81 divided by 9 is 9, isn't it? So this is a neither. Which brings us to the explicit formula here on number 6. If that's an explicit formula, we should be able to put it into the y equals of our calculator and grab those points down off of the table here. So we'll have 12 minus 3 times the quantity x minus 1. I'm going to go to the table, start at 1, and I see my numbers are 12, 9, 6, and 3, aren't they? The first term is 12, then 9, then 6, and then 3. If I want to know the 10th term, I'm just going to go down here until x is equal to 10, and my y value is negative 15. So let's see, our variable is k. K sub 10 is going to be negative 15. If this is going to be subtracting 3 every single time, because it's linear and the slope is negative 3, this will be arithmetic. Okay. Number 7 says we're going to write the explicit formula for the sequence defined in problem number 1 above. If we go back to problem number 1 above, it was recursive, wasn't it? Okay, and so we want to write an explicit formula. It's not only recursive, it's recursive geometric. So you need to go to your blue note card, and if it's recursive geometric, we want to write down it's recursive as geometric, and we want to flip it over into an explicit formula. Okay? So if I want to make an explicit formula, then I want to look up the geometric explicit formula. So on my note card, the geometric explicit formula says I want to go g sub n equals g sub 1 to r to the n minus 1 power. All right? So my nth term, by the way, that's a subscript, needs to be a little bit lower. It's going to be my first term. Now, if I go up here in this problem and look for the first term, that's going to be given in my recursive formula. The first term of this was negative 4, wasn't it? It's negative 4. Okay? And then I want to multiply by r, the common ratio r, Well, we said, based on this list of numbers right here, that this was dividing and every time we were getting -3, weren't we? So we're going to say that this is -3. So I want to take -3 and raise it to the n minus 1 power. All right? I probably should have used r for the variable, but it might have been confusing with this being the common ratio r, so I think I'll stick to my g. Okay, number 8 says we're going to write a recursive formula for the sequence defined in problem number 2 above. So rather than keep going back and forth, I'm going to write this down. It was c sub n is equal to the opposite of n plus 7. I want to write a recursive formula for this, and it was arithmetic, right? Okay, well I need to know two things to write my arithmetic recursive formula. I need to know the first term. I'll call it c sub 1. Well, I can look back and I can see that c sub 1 was clearly the number 6, right? And then I need to know my common difference. All right, well the numbers in that sequence were 6, 5, 4, 3, so this is going down by 1, so the d is going to be a -1. So now my recursive formula, I'm going to make a set bracket on the left. I'm going to identify the first term, c sub 1. I'm going to keep with c this time because c is the variable here. The first term is 6, and then the nth term is the previous term, c sub n minus 1, and then I want to subtract 1, which is the common difference. And then I always say out here on the end, this is for integers that are greater than 1. We're talking about the n standing in for the term number, and term numbers need to be integers, and in this case it needs to be greater than 1. We're not going to talk about negative terms on this. Okay, and last but not least, it says find an explicit and a recursive formula for this geometric sequence. So they're already telling me that it's geometric. So I need to label the first term here, the first term, which is 2/3, and then we need to find r, the value of r. So I want to take 1 and divide by 2/3. 1 divided by 2/3 is going to give me 3/2. What if I took 3/2 and divided by 1? I would also get 3/2, and so on. So we're finding that the common ratio on this is 3/2. Okay, I'm going to write my explicit formula first. So I look on my blue note card. It's under geometric sequences. The recursive formula says that I'm going to use g sub n is equal to g sub 1 r to the n minus 1. So I'm going to say that my nth term is equal to my first term, 2/3, times my common ratio, 3/2, and then that would be to the n minus 1 power. Okay, I'm not going to multiply the 2/3 times the 3/2 and try to do any canceling, because under order of operations we would have to raise this to the n minus 1 power first before we multiply by 2/3. Okay, the other chore we have to do is find the recursive formula. We're going to start with a set bracket on the left. We need to know that first term again. G sub 1 is 2/3. And then you want to do every term thereafter. So G sub n then would be equal to r, which is 3/2, times the previous term. Probably didn't need parenthesis there, but the previous term, which would be, I'll just make it into a times for a star, g sub n minus 1. Okay? Then we're going to say this is for integers n greater than 1. For integers n greater than 1. This would look better. I'll rewrite it down here. It's 3/2 times the previous term. So g sub n equals 3/2 times the previous term. Okay, I hope that is enough to help you remember what it was you learned in Algebra 2 last year, because your entire lesson will be on this. You're going to start out with Lesson Master 8.1, and it'll mostly be about arithmetic formulas, and then you'll get into Lesson Master 8.2, which will mostly be about geometric. But by all means, there's anything that's free game for them to ask you about, since we studied that so extensively last year. Again, if you have any trouble on any of this, please let me know. If not, have at it and have a good time remembering how to do that.